Welcome to AP Statistics, Chapter 14, Part 2, Confidence Intervals for the Slope of a Line and Conditions for Inference on the Slope of that line. So today's lesson is going to be all about slope. And so it's important to recall that we have a symbol that we use for the slope of a population. And that slope is, or that symbol is the Greek symbol beta. And we should bear in mind that since it comes from an entire population, this is a parameter. Meanwhile, we should remember that we also have a symbol we've been using for the entire year for the slope of a sample, and that's just the lowercase letter b. And so, of course, since it's from a sample, this is a statistic. Okay, and let's take a look at our example. The following regression analysis is Minitab output from the 2012 U.S. News and World Report undergraduate university rankings of the top 25 schools. We suspect that school rank explains acceptance rate. We are interested in predicting the average amount by which the acceptance rate of a school changes when the rank increases by 1. In other words, we want to analyze the slope of the least squares regression line. So here's our output, and here's our least squares regression line, and we can see that it looks pretty clearly like it's got a positive slope. What we're going to do is we're going to construct a 95% confidence interval for beta, the slope of the regression line. So let's remember confidence intervals. All of them have essentially the same format, which is you start by taking the statistic, which is the product of your study. And then you add and subtract a margin of error from it. And that margin of error is given by a critical value. That critical value is a result of the type of test that's being run and the size of the confidence level. We take that and we multiply that by the standard deviation. So in the case of the particular test or the particular situation that we're in here, our statistic is going to be the slope that came out of running the Minitab regression here. And that slope see if I can zoom in. Looks like I'm zoomed in as far as I can, so we're going to have to work with that. Right here we have our predictors, and this one is rank. And since this is rank, and this is the coefficient to rank, it means that this number right here, the 0.7752, that's going to be our slope. Meanwhile, our critical value here is a t-score with n minus 2 degrees of freedom. And the reason for the minus 2 is basically because we have two different variables here, acceptance rate and rank. And so it decreases our degrees of freedom just by a little bit. There were 25 schools that we analyzed, so we're going to have a T23. And we have a 95% confidence interval, so you can get this information from your calculator. I really think it's easiest to look at the table in your book. And in your book, right here is 95% confidence level, and we just move up the t-table until we get to 23 degrees of freedom. And the number that I'm pointing at here, I know you can't see it, but it's 2.069. Now for the standard deviation. What we're really interested in is what's called the standard error of the slope. And I'm going to give you a formula for it, and here's what the formula looks like. It's the standard deviation of the y values, which we looked at a formula for that last time, divided by the square root of the sum of the square of the deviations of the x values. Okay, and mercifully, we're never actually going to have to calculate this by hand because it's always going to be given to us here in our regression analysis. You can see that we're interested in rank. The first value gives us the predicted value of the slope. The second value here gives us the standard error of that slope. So we want to take this number, 0.1189, bring that around and use that as our standard error. Okay. All right, so now that we've got that in place, let's construct a 95% confidence interval. All second semester, we've had a 3-step process by which we come up with these confidence intervals. And that first step is to write the formula. So statistic plus or minus critical value. I'm going to call it T23, T star 23, times standard error of B. You do not need to write this formula right here. If you call it this, you're good to go. Okay. So the second step is we plug in the values that we have. The slope, or the prediction of the slope, is 0.7752 plus or minus. Our t-score is 2.069 multiplied by our standard error, which is 0.1189. Our last step is to write this as an interval. So I did the math and found that the lower value is 0.53 and the upper value is 1.0